Hello, everybody. Can you all hear me all right? All right, perfect. Now, I know the walls are thin here, so I'm going to go a bit more loud than usual just because I think it's like a battle of dominance here, right? Room one tends to win, so let's make it happen, all right? So first of all, thank you for coming to this 9 a.m. talk on the last day of the conference, right after a rock concert and a karaoke night. How many of you here are hungover right now? No one. All right, we have a responsible crowd here. I am very glad to hear that. So I want to start off by setting some expectations, because again, this is the last day of the conference. If this is not the talk you expected, I will not feel bad if you stand up, walk out, find something that fits you more. Go for it. You know, I'm doing this talk hopefully to be helpful. The big thing is this is an introductory level talk. That means I'm not going to dive directly into the code and tell you how to implement things using a specific tech stack. Instead, I'm going to tell you about why you shouldn't use microservices even before I talk about when you should. Of course, I am talking about .NET Aspire. How many of you here are here because you saw .NET? Oh, fantastic. How many of you here are here because of .NET Aspire? You saw that in the title? All right. Expectations are high. But my hope is that the learnings that I can give about how to avoid the most common mistakes of microservices can be broadly applicable. Sound good to everyone? Let's dive in. Now, before I talk at you for the next hour, feels polite to introduce myself. My name is Jiachen. I work as a product manager at Microsoft. Currently, I am on the team working on Azure Container Apps, but before then, I spent a few years on the .NET team. How many of you here are .NET developers? Okay. Out of curiosity, how many of you have been doing .NET for more than 5 years? It's like everyone, okay. 10 years? All right, this might be a stretch, but 15? All right, all of you in the back, I see. I'm remembering your faces because I just know y'all are gonna be asking me the hardest questions during the Q&A, so I need to be prepared. Now, I've worked on some tools that you might have used before. How many of you here have used Entity Framework Core? All right, great. How about NuGet Package Manager? Fantastic. I was going to say, if you've been using .NET for 15 plus years and you've never touched NuGet, I would be concerned. I would be a little impressed, but mostly concerned. Now, I need to give a disclaimer here. Anyone in the audience have no idea who David Fowler is? All right, okay. So, he wrote NuGet, he wrote SigNoir, a couple other things you probably used. He's essentially Taylor Swift for .NET developers. I bring him up because his latest baby is .NET Aspire. It was his team that built it from the ground up, and I'm sorry to break it to you, but I am not David Fowler. I know the resemblance is, it's uncanny, but, you know. Aspire was after my time on the .NET team, but my job today is to make sure Aspire works well with everything else, essentially, all the other technology, all the other tooling. So if you're looking for a technical deep dive into Aspire architecture, I am not the right person to ask about that. I will say there's a couple ways to reach Fowler, right? You can go in front of a reflective surface, you can say his name 3 times, and he will appear and info dump to you about service discovery. I don't know if that's a threat or a con. A threat or a pro. I think it depends on the kind of .NET developer you are. Or you can just DM him on Twitter. He is very active. In this next hour, I'm going to tell you about the problems that devs face while building microservices and when they're not a great idea. But I'll also tell you about how to build them well, guidances that show you how you can build quality microservices without sacrificing time and money. I'll talk through 3 specific features of .NET Aspire and what problems they can solve. Then I'll finish off by talking about deployment and hosting, because building quality microservices does not start and end on your local machine. Once it's out in the wild, you need to be able to get information about how your application is working. You need to be able to catch errors early, identify performance bottlenecks, and figure out how to optimize continuously over time. How many of you have heard of microservices? Okay. How many of you feel confident that you can explain what microservices are in a single sentence? Okay, like 3.5 hands. I see a really confident one here. But microservices have become a bit of a buzzword these days, by which I mean it's hard to define what they actually are. People just know that it's good. The core idea of microservices is that applications work better when they're in individual pieces that connect together as opposed to one big one that does everything. Now think of it like working on a team instead of having one guy who's a 10x developer who does every single thing. Now that sounds pretty good, right? And I have the slide about benefits. I'm going to keep it short and sweet. I'm sure you've encountered some of these before. Great, we've just established that microservices are awesome. They show off the power of teamwork, kumbaya. But how many of you here have been on a terrible team? I'm talking about hour-long stand-ups. Your manager doesn't know how to divide up the work. One guy knows everything, and when he goes on vacation, everyone else is just screwed. How many of you have experienced that? Okay, just a couple people, all right. Lots of really fortunate folks in the audience here. Glad to see it. What I'm getting at is while microservices can give you the benefits of being on a team, they can also give you some of the terrible parts too. How many of you here have been burnt by microservices? Okay. I see the dead look in your eyes. You guys get it. Now, for the rest of you who are lucky to have avoided that so far, I'm going to take 3 minutes and show you one of my favorite videos on the internet that will explain exactly why. Yeah, okay.
Why we're taking 3 years? Look, it's not that simple, all right? I have priorities, my team has deadlines, we have other deliverables.
I'm still not understanding this. Why is it so hard to display the birthday date on the settings page? Why can't we get this done this quarter?
Look, I'm sorry, we've been over this. It's the design of our back end. First we have to call the bingo service. See, bingo knows everyone's name-o, so we get the user's ID out of there. Then from bingo, we can call papaya and MBS to get that user ID and turn it into a user session token. We can validate those with umnop, and then, once we have that, we can finally pull the user's info down from Raccoon.
Yeah, but couldn't the Raccoon team basically just...
No, Raccoon isn't guaranteed to have that info. Before we do this, we have to go to Wingman, do a query to see if the user's willing to take it to the next level, or if they're just playing the field. Now, Wingman is cool, but he doesn't store any user info himself. He has to reach out to other user info provider services, like RGS, Barbie-Doll, Ringo2, BLS. But how does it know what all the user provider services are? Well, for that, it has to go to Galactus, all-knowing user service provider aggregator. And while Galactus has omniscient knowledge of all current user info providers, it doesn't have future sight or knowledge of past user info providers, so it expects a time range. To get all the current user info providers, we need to pass a time range with the current time and a time representing the end of the universe, which we get from EKS, our entropy chaos service. EKS is being deprecated at the end of the month for Omegastar, but Omegastar still doesn't support ISO timestamps like they said they would a month ago, so until Omegastar gets their fucking shit together, we're blocked. We can't get signed up for our use case, we can't use EKS, there's nothing we can do. So Galactus won't be able to find our new birthday boy provider, which means Wingman won't know how to talk to anybody, which means I won't be able to find true love and I'll die alone. I'll die alone, without ever knowing love, without ever knowing it's my birthday. We're blocked, okay? We're blocked, you sad, pathetic little product manager. You think you know what our users want? You know nothing of my pain, of Galactus's pain. You think you know what it takes to tell the user it's their birthday? You know nothing. Delivering this feature goes against everything I know to be right and true, and I will sooner lay you into this barren earth than entertain your folly for a moment longer.
All right, so clearly this is a blocker. No problem, we'll push this out another 2 to 3 years or so. Learned a lot today, love Galactus. But we'll talk next week about adding middle names to the profile. Awesome, sounds good. Take care.
All right. It's funny because some of you are laughing and some of you seem to be going through war flashbacks there. So sorry to bring that back for you. Lots to unpack here, huh? Now, the big con of microservices that you just saw is they are essentially inherently more complicated than monolithic architectures. There is no getting around that. Juggling a dozen different pieces is going to be harder than dealing with just one. And if communication is not done efficiently, that's going to make things exponentially worse. General rule of thumb is that the default choice should be simplicity, not complexity. Maybe getting information about a user's birthday should not require half a dozen different microservices. Just something to think about. More complexity means more investment, especially if the developer team is pretty small or doesn't have the right kind of structure for distributed application development. No matter how well your application is designed or split up and autonomous, if the team itself is not, that's not going to work out for you. That's why sunk cost fallacy is a real thing with microservices. You've already poured hundreds of engineering hours into making it happen. It's hard to walk away, even if it turns out that microservices don't actually work out that great for your team. The last issue with microservices is, in my opinion, the most dangerous. With the first one, the second one, high complexity, upfront investment, if you take an honest look at your team and scenario, you can get a good idea if it's a good fit for you. But this is more subtle. Just dividing up your application into different parts does not mean that you're actually doing microservices. If your services are not decomposed properly, if they're still tightly coupled to each other to the point that changing one thing requires changes in half a dozen others, you're missing out on the benefits while still taking on the complexity and high investment. It's like you're building with Lego pieces because you want to be able to rearrange things, but you're super gluing each additional piece as you go. You end up with the worst of both worlds. That's called a distributed monolith. There was a talk earlier this conference about them. If you did not attend that talk, they're essentially what it says on the cover, right? That was actually about something else. Distributed monoliths didn't get talked about in this conference, so I guess I'm the first one. But there is a pretty popular talk presented at a few previous NDCs from a consultant who's worked with a lot of teams who have tried microservices and discovered, oh shoot, I put all this time in, but I didn't actually succeed. He estimated about 90% of the teams that go to him realized that they came out with a distributed monolith instead. Now, that's a pretty scary number to me. Usually, developer teams don't realize they've built a distributed monolith until they are in production, they look at a few of the endpoints and go, we have a bit of a performance issue. Or even worse, they've been running it for a couple months and they realize it's just getting worse over time. Now, the hard thing here is there is no easy way to fix one once you have it. You either have to just deal with it or eat the cost and start again from the very beginning. That's because distributed monoliths come from design choices. It's not an implementation one, so it's not like you can take a single step back and just tweak how you made it happen, and it suddenly all works perfectly. Now, here's an example of a distributed monolith. You'll notice that even though this app is divided up into a couple different services, a lot of them are calling each other directly. You have multiple services that have the same functionality. The same database gets used by a bunch of different things. Now, these are all design choices that's going to result in your application getting more complex and performing worse over time. Start with the disclaimer that there are a lot of reasons why this could happen. These are just the top 3. In addition, they're rarely independent of each other. Usually, if you make mistake number 1, you're going to end up with all the other mistakes too. Now, I get it. Microservices sound great on paper. Everyone and their mom are recommending it for building a modern cloud application. But the reality is, monoliths aren't always bad, and microservices aren't always good. Even when they're perfectly designed, tightly meshed, cloud native, whatever, there are just some scenarios where they are not a good fit. In the past few years, there's actually been a few cases of high-profile teams moving back from a microservices architecture. And in my opinion, it has a lot to do with microservices being pretty black and white. There's no real discussion of what lies in the middle when there's actually plenty of different options. You can break out a few specific services as microservices, let's say, and keep everything else as a monolith. Or we can talk about the modular monolith. Now, this is the one I'm getting at, where there was a talk earlier in the conference. It's essentially what it says on the cover. It is a monolith, but it's made modular in a way where you can easily migrate to a full distributed architecture when you do want to, but you get some of the benefits now. If you're just getting started, if you don't know the exact needs of your app, microservices is something that you need to be careful about considering because they are more difficult to get started with and they're hard to iterate on quickly. So if your priority is speed and simplicity of startup, more so than performance and scalability over time, starting off with microservices is not going to give you the right priorities. And if you don't need something complicated enough to require microservices, maybe a monolith is enough. Now, I've talked before about how important team structure is, and I want to emphasize that microservices is not just about code. It's the philosophy of how development should be done. If you can't have separate autonomous teams working on separate services, or they require a lot of communication still to get anything done, you're not going to get the full benefits. Now, in my opinion, the overarching issue with going with microservices or any other hyped up technology, AI included, right? Like I said it, sorry. It can very easily turn into a case of when you have a hammer, everything looks like a nail. If you start with the approach you want to take instead of the problem that you want to solve, you end up adapting your requirements to fit the microservices model instead of the other way around. You split it up, not because it makes sense to do so, but because you just want to split it up. It sounds cool. Now, there are plenty of cases where that doesn't make sense. If all the different parts of your application depend very heavily on each other and they would need to scale together anyways, if you're using the same database across different parts of the app, there's a lot of shared functionality that you would have different services taking care of. Even if you break up the code, you're not going to get the real benefits. Leads us to mistake number 2 here. Now, this is pretty common because it's not like there's clear and fast guidelines around how big or small to make each of your services. Personally, I think microservices is not actually a great name for distributed applications because it's not about them being micro, right? It's not about, oh, it has to be under a specific line of code, like, in order to be small. It's about mapping services to specific functionality, not about the size itself. Now, big consequences here. If your services are too big, again, in terms of they do too much, not in terms of lines of code, then the start time and the computing resources needed by the container are so much that you're not going to get actual benefits like dynamic scaling or failover, which is the automatic switching over to a backup once the primary fails. You can also end up with services that are just not really autonomous or independently deployable. And at that point, why are you doing microservices at all, right? On the other side, if they're too small, you end up with more complexity than you need. Or you split up functionality that should have just stayed together in the first place. Let's say you have a feature that takes in data and then validates it by a specific rubric. You can split it apart, so you have one service that takes in the data and another one that validates it. But the one that validates it is so dependent on the first one, right? Like, you need to check if there's actually data coming in. And because it's a specific rubric, it's not like you're going to use that validation for anything else. At that point, you're just splitting it up to split it up. Last but not least, if you have multiple services that have the same functionality, you're not doing microservices anymore. You end up with a service-oriented architecture model. And you get the limitations of that approach. You end up with a single point of failure, and you find that services can't be managed individually because of shared functionality. There tends to be shared resources. Now, that's a big problem, especially when it comes to shared data. Here's an example of a distributed monolith where services are not correctly split up. You can see that A and C are connected to service B, and they work together to do one thing. If any of these services go down, the other two go down as well. That brings me to the last thing to watch out for, which is that of tight coupling. Now, if I want to define that with a single sentence, it is when changing the state of one component is going to change the state of others. Let's say you have a back-end product catalog and a front-end that displays the contents. Ideally, if your backend goes down, your front end should still be able to tell users, hey, like we can't access the backend. Ideally, it shouldn't just crash along with it. Well, in conclusion, there are a lot of ways where tight coupling can happen. Here are the top 3. If the services call each other directly, highly dependent on each other, then you probably shouldn't be using synchronous API calls all the time. You should be able to have the functionality separate enough that one works even if something else doesn't. Now, if services are accessing the same data sources, especially the same database, if one service writes to the database in the wrong way, then it affects everything else. Now, a smaller issue here is maybe you're not optimizing by choosing the right database for the scenario. You're just trying to force it in order to fit the database that you do have. It's a situation of jack of all trades, master of none. Draws me to the last issue here. And this one is a bit mean because it turns one of the benefits of microservices into a design flaw. I used the Lego blocks analogy earlier, but there are consequences to using the same block again and again. If you end up having to change the block, so it's better for one thing that you build with it, is going to affect everything else that uses the block too. Sure, sharing code through abstractions, through dependency libraries is efficient, theoretically cleaner than just copy and pasting your code every time you want that functionality. But honestly, duplicating is going to be better than hasty abstractions because you can still tweak each individual one to fit the scenario. If one service requires a change to that shared library, that still has to be dealt with by all the other services that are using it. You'll see here that services A and B and C and D, they all share the same database B. So not only is the shared functionality going to go down when any of these 3 services running into an issue, any problem with database B is going to affect your whole application. Brief review of these 3 mistakes. If you use microservices when you don't need them, if you break them up into services that are either too big or too small, or they rely too heavily on each other, you're going to end up with a distributed monolith instead of microservices. And I know what you're thinking, wow, that's a downer. Why would I want to put myself through that hell? So let me bring back the benefits page I showed you at the beginning of the talk, because my goal here isn't to bash on microservices and ruin them for you forever. They can bring you plenty of benefits. I'm just saying that it takes more effort and intention than you might think to actually access them. You can even think of it like microservices have so many benefits that hundreds of thousands of developers over the past decade have put themselves through hell in order to use them. Now, I don't have a magic formula for avoiding all these problems. If I did, I would not be giving a 9 a.m. talk about microservices. I would be in a chateau in southern France sipping natural wines, surrounded by my flock of geese. Clearly, I am not doing that right now. But I do have a couple general guidelines, and spoiler alert, I have a tech stack to recommend that helps you follow them. Now, the most important rule to me personally is to invest in observability early. I want to emphasize that it's not monitoring, which is seeing what comes out and saying, oh, that's not what I expect. It's about analyzing both the inputs and the outputs to the system to understand its state and to find the root causes of issues. Microservices are complex. Just as any other complex thing, they tend to end up as black boxes where you see what comes out, but you have no idea how it got there. Look, I doubt that those 90% of engineering teams deliberately built a distributed monolith. They didn't make a deliberate decision to design overly complex, tightly coupled architectures that crash and burn in terms of performance. I think it's more likely that they didn't get enough insight early on into how these services were performing together and separately until it was too late. Now, there are plenty of architectures that sound great in theory, but not in practice. Having access to logs, metrics, and traces early on in your development process is going to help you find issues early. It's going to help you figure out how to solve problems instead of slapping on a duct tape solution later down the line. And it can help you identify and simplify complexity in your microservices design while you still can change. Now, the best way to decide if microservices are right for you is to try it out, ideally with minimal investment. To do that, you need to know how your app is working under the hood in order to experiment and iterate. Now, this last piece of guidance is a bit different. The obvious benefit to using libraries and packages that are already out there is you have to do less work. But the more subtle one is, we're still going with the Lego analogy, building with the official pieces tend to result in less problems than if you 3D printed one yourself. I talked earlier about how hasty and inefficient abstractions can hurt your application, even more so than just copy and pasting code. There are plenty of libraries and packages that are part of the broader ecosystem of microservices, and these are tried and tested. They are going to be more trustworthy than just reinventing the wheel, going with your own thing. Now, the theme here is if you want to do microservices well, you need to go at it at your own pace. Now, to some degree, it's common sense, right? If you can't swim, then you probably don't want to jump right into the deep end. You want to be able to take intentional steps forward, usually without investing too much upfront. You want to be able to get back the necessary information to decide whether it was the right step to take and have the room to take a step back. Fortunately, in most cases, that's easier said than done. When you're new in the first place, you rarely have a clear idea of what steps to take. Observability isn't exactly the easiest thing to set up, and it's not easy to roll back changes when it comes to how your code is split up across nodes in a Kubernetes cluster. That is where .NET Aspire comes in. So I already saw that most of you have heard of .NET Aspire. How many of you think you can define it confidently in one sentence? No one. That's kind of what I figured. Now, just like microservices, it's been a bit of a buzzword to the point where people don't really know what it is, just that it's supposed to be good. The elevator pitch here is it's a tech stack for building apps that are designed to work well for the cloud. I'm going to be upfront here. This is not a collection of shiny, new functionality that's untested that just got built from scratch over the past year. It is a smoother and more intuitive way to use tools and features that have always been there. It just allows you to do it without going through walls of text of documentation that might be from 2008 or something, or doing your own DIY work in order to make things happen. 2 words here I want to emphasize. Opinionated. There is a lot of information out there around microservices. Lots of noise that you have to comb through. You get bombarded with decisions up front without getting the actual information to make them. Customization is great, but at some point, you just end up spinning your wheels until you make a snap judgment that comes back to haunt you like 5 months down the line. Instead of presenting all the options that are out there, Aspire points to a few and says, hey, this might be a good place to start. And for the big red buttons in microservices development, where you probably shouldn't push that, right? Aspire actually puts a sign up that says, do not push. And because we're human beings, like, there's still people who are going to push it, but at least you were warned. Aspire is also code first. Building and managing microservices can be hard for devs who don't have a lot of infrastructure experience. Aspire puts a lot of unfamiliar concepts and actions into the form of C# code. Now, that's easier to work with, but that also makes changes easier to roll back. You can just delete the code in order to make that change. The point I want to make here is Aspire wants to make microservices development more accessible for the average software engineer, not just for people who know their way around infrastructure. Let's get specific. The first thing that Aspire does is it integrates the process of putting your code into containers and orchestrating those containers into the rest of the development process, instead of making it something that you have to go out of your familiar tools, do it on the side with Docker. How many of you have written a Docker file before from scratch? Good amount of people here. Now, if you already have that experience, you can keep doing that, right? This isn't a replacement. Instead, it's a way to get started. It gives you a template that you can build off of and customize over time. But Aspire gives you a way to just get things up and going at first, just to get it working, and then you can tweak it as you go. This helps you get into containers at your own pace. It also helps you learn, because I don't know about you, but I learned best not while reading a massive piece of documentation, but by playing with the code myself. The second feature here is the ecosystem of Aspire packages. Again, it's not reinventing the wheel. This is literally a filter on NuGet that you can slap on and you find all the packages. It takes the most popular packages for microservices development and makes it easier to add to your application. So think about it like buying a shelf that comes with the exact nails you need to put it on the wall, instead of having to go to the hardware store to figure out the right size, the right material, whether or not you need additional things to make it stick on. Now, not only are they ready to be integrated, they're also already configured for observability. So the idea is you add on a package, you can already see how it's going. The last advantage of these packages is that they are curated and supported. Remember Omegastar from the video and the pain of a deprecation that has a replacement that isn't exactly reliable? That doesn't really happen with Aspire packages. I want to quickly clarify, this isn't just the .NET team gets to build Aspire packages and everyone else just consumes them. Anyone can build an Aspire package. It just so happens that because Aspire came out, it GA'd like 6 months ago or something like that, the vast majority are from the .NET team right now. The last benefit I want to talk about is the Aspire dashboard. I talked about how observability is available from the start for packages and libraries that you add onto your application. That's also true for any Aspire application. Every time you run one, no matter how basic, a UI dashboard will spin up and show you live information about how each of your services are running, as well as the performance of the overall app. So I'm talking logs, I'm talking traces, and metrics, and they're all coming from OpenTelemetry, which gets automatically configured for everything Aspire. Yeah, I see some celebration over there. I appreciate the enthusiasm. This isn't limited to .NET microservices, by the way. If you have some parts of your microservices that aren't written in .NET, it's still going to work right out of the box. If you're not working with any sort of .NET, you can just take the dashboard as a container and make it work for your project. Now, let's take a look at some code. I'm going to give you an example of how the dashboard can help you identify inefficiencies and how to use the Aspire packages to easily bring in new services that can streamline how your app communicates. I'm going to be working with the eShop Lite sample. I'm not going to go into detail here. It's essentially a pretty standard e-commerce site. There's a front-end Blazor app, there's a back-end web API. They get information from each other, so on. Now, right now, whenever the user wants to see the items in their shopping cart, they got to go through like all 7 steps of that, right? You can configure and resource every service here perfectly, but doing that every single time a user refreshes their page is not going to be the most efficient. Now, one way we can tighten the loop here is instead of going through that entire 7-step process every time, you can cache the products list the first time you do it. So instead of going to the database to retrieve it, you can just go to that cache store. So I'm going to use an Aspire package to bring in a Redis cache store, get it hooked up to our application, and take a look at our dashboard to see essentially what we were able to do. So I recorded this like this morning or something because I figure y'all didn't pay or your companies didn't pay 1,600 euros to see me type. But essentially, I'm going into NuGet Package Manager, finding the Redis package. Are you able to see all right? I know the lighting here kind of, but you add it in, and you add it to your app host, which is sort of the connective tissue between all the different services. And it's a pretty intuitive process. You say add Redis, and Redis is added. And it's under the friendly name of Redis. So you're not going in and saying, oh, like what is this specific port? You just reference Redis whenever you want to use it, as you see here, right? I just add with reference Redis to the front end. Wait, sorry. Yeah, to the front end. So now I'm going to add one more Redis package, and this is me going to the actual front end to get the Redis that actually captures the data. So once that package is added, I go into the front end, I say add Redis, the specific version of Redis, using the friendly name. And then I use it. Now, the last thing I want to do is configure how that cache store works. And I am able to do that with this line of code. You can see me failing at typing, so I can prove that this was not AI generated. So right now I'm setting the duration to 10 seconds. So it means that if I'm refreshing within 10 seconds, then the data is consistent. But if it's longer than 10 seconds, then it calls the database again. So right now you see the Aspire dashboard that gets pulled up. And you can see here that, at least to start with, we're calling all the way to the database. But now when we refresh, well, OK, so right now, when we refresh, we're still calling from the database. But now again, we can see that it's coming from Redis instead. Cool. So as you can see, after that initial call, our loop gets a lot tighter. It's more efficient than before. Now, I've given a bunch of talks around Aspire over the past few months, and there's a couple questions that keep coming up. And it makes sense because new releases tend to come with deprecations and improvements that replace the things that worked before. Aspire was built with a different approach. Instead of reinventing the wheel entirely, a large chunk of Aspire is what was already there and making it more usable. Now, just because you have that option doesn't mean that you have to do it all the time. Because of that, there aren't any one-way doors where if you choose to go with Aspire, you just can't go back. Most of these improvements are in the form of code and files that get generated, so they can always be deleted or customized. It's not like you click a single button and you get a totally different experience and you're just stranded there. Now, that brings me to the biggest worry people have about Aspire, which is, cool, I'm getting more abstraction. Where's the catch, right? Like, where's the cliff where I can't do what I want to do, and now I need to learn everything from scratch? Now, Aspire was developed with this concept of progressive disclosure in mind. Now, that basically means you shouldn't have to learn everything up front before you even need to use it. Because the abstractions are in the form of code and other existing building blocks, all the details are still there. They're fully accessible when you do want to see it. If you want to learn how to write your own Docker file, you can generate one to start, get a sense of the general structure, and go off of that. Same with the deployment pipeline that I'm going to actually show in a couple minutes, but that generates the infrastructure information in the form of bicep files that you can look through yourself and customize to your needs. And I'm going to make a disclaimer here because I'm trying to be honest even when Microsoft might not particularly like it, but Aspire is very new. It does have a few parts that are not fully baked. It is able to build production-ready applications, but it depends on your specific scenario, what is available out of the box to do the thing you want versus how much you need to DIY with the rest of .NET 8. Now that we've talked about local development, let's talk deployment. As you can probably guess, deployment gets a bit gnarly with a dozen different microservices as opposed to deploying a single app. And because of that, the experience can sometimes be what you see here, where you have a beautiful, fully functional local development experience, and then you get to deployment and all hell breaks loose. How many of you have heard of AZD? All right, a couple people, especially the ones in the back. All right, 15 years plus of .NET development. I like that. So the Azure Developer CLI is the recommended way to deploy Aspire apps, but it's definitely not the only one. And if you've already done a lot of Azure deployments, you can still do what you've always done. In fact, AZD isn't really all that different from that. Your deployment is still based on bicep, and if you're not familiar with what that is, just think of it as infrastructure as code. But instead of having to write the bicep files from scratch, AZD generates them for you so you have something working from the start and you can build off of it over time. Deployment boils down to two commands, azd init, that provisions all the resources, and azd up, which deploys to Azure. That's it. Now, that's nice and fast and easy, right? But it's also kind of magical. You know, you put in two commands and everything gets done for you. You kind of have to trust that it's doing it right. It doesn't have to be that way. You can type in the single command azd infra-synth, and it shows you all the work that's being done under the hood based on existing tooling. You can service all those files and customize them however you want, or you can take those files and plug them into your own deployment pipelines. This isn't a replacement. This is an assistant. Now I'm going to talk a bit about hosting. How many of you here have heard of Azure Container Apps? Wow, good amount of people. This is actually kind of surprising. How many of you have actually used it? OK, still a good amount of people. It's an Azure service that was made generally available just a little over 2 years ago, which is like 2 seconds in terms of Microsoft times. And it's for hosting applications that are in containers. Now, that includes microservices, but it's not limited to it. And some of you might be thinking, like, oh, like, what do you mean this is the default place to hold Aspire apps? What about Kubernetes? Kubernetes is the microservices thing, right? And Container Apps was built off of Azure Kubernetes Service. It's the same functionality underneath. It's just easier to access. Now, if you're new to microservices, honestly, Container Apps is probably the better option. There are less decisions that you have to make up front, even ones that seem unimportant right now, but it's going to screw you over somewhere down the line. There's more features, functionalities, integrations that's available out of the box, less that you have to DIY. And there is a range of what you can build with it. So it's not like you dive into the deep end with super intense microservices. You can really use it for anything along the range of applications that are in containers moving towards microservices. And if you hit the point where container apps is not giving you what you need, it's working off of a pretty similar mental model. So it's pretty easy to port it to an actual Kubernetes cluster. But if you are a microservices expert, you're sure about the microservices approach, or you have requirements that container apps cannot meet. So for example, you need to customize your networking through access to the control plane API. And if you have no idea what I mean by that, you probably don't need it. Then Azure Kubernetes Service is the better option for you. And they actually recently announced something called like AKS Automatic, which should make it a bit easier to get started. I don't know a huge amount of that. Now, I want to emphasize that Aspire deploys to both of these. It deploys to a whole bunch of different options, right? It's not saying, oh, go Azure, or like we're going to pretend you don't exist. There's really good integration with AWS, with a whole bunch of other sort of, you could just take the manifest and deploy it to your own private cloud if you're not able to use the big corporate ones. Aspire maps pretty intuitively to container apps. One solution becomes one environment. Each microservice becomes one container app. Now you'll notice that revisions are different versions of a container app. Replicas are duplicates of a container app that gets created as it scales up. I'm going to really briefly talk about the architecture of Kubernetes and container apps so you can have a better understanding of how it works. How many of you have worked directly with Kubernetes before? Okay, a couple people, brave souls, I see you, I salute you. But we also have a good amount of people who have not. The short and simple version of this is when you deploy to Kubernetes, you get a cluster of nodes. Each node has containers that contain the code that's running, as well as pods that contain the compute for running them. And you can see the structure on the screen. The pods host and run the containers that contain that code. But in order to run the code, you also have to deal with, I think like it's like a kubelet, a container runtime, a kube proxy. I feel like they just take English words and they add kube at the beginning. Anyways, you can see that maintaining a Kubernetes cluster requires knowledge beyond just how your code should be divided up and how your services connect to each other. You also need to get an understanding of the infrastructure that makes your code run. In container apps, each environment maps directly to a cluster. Then you have container apps inside those environments, which are like nodes. And that's it. You essentially only have to worry about how your code should be broken apart instead of thinking about pods and containers as separate pieces, like let alone the kubelet and the kube proxy and everything else that makes the code run. As you can see, they have very similar structures. So if you have to move over, you already know how things are divided up. You just have to learn those extra details of how the infrastructure works. The other difference, and I'm going to skim through this pretty fast, is you don't have to DIY customize each individual node for your particular need. There's a couple genres of things you can a couple genres of container apps that you can use. There's, container apps, which we've been talking about so far. Those are pretty standard. But then there's also jobs, where there's something you want to get done and stop running once it's finished. Maybe every night you want to generate some reports from data. Maybe you have messages that are coming in, you want to process it and just end. If you have a constant stream and you don't want to ever go down, then container apps might be the better options. Then there are sessions. So sessions get talked a lot about in the context of AI because it's for running code that you want to keep away from the rest of your app. Maybe you have high security requirements. Maybe you're just getting that code from random people on the internet and you do not want to touch that until you have to. All three of these can live in the same environment, so you can decide to separate out some functionality into the type of resource that fits best and keep the rest where you want it. I'm going to really quickly talk through what our application looks like in container apps and what you can do with that platform. Again, Aspire works with everything. Like you probably want to set up similar features no matter where you go. This is just one way of doing it. The .NET Aspire dashboard that you saw locally is available out of the box on container apps. And that's going to show you live data about how your application is operating in production. And just like locally, you can use it for non-Aspire apps too. There's single revision mode. This is one of those small quality of life features that you're not going to think about until you run into it head first and things break. But the idea is whenever you push updates to a container, Container Apps handles the redirecting of traffic so users don't experience a gap in services. You have scale to 0. Now that's a big serverless thing, another buzzword. If your application is not being used by anyone, you don't get charged money. That's essentially what it is. You can set it manually, or you can set up scale rules that has it going in response to events. That brings me to the end of my talk. What I want you to walk away with here is you do not actually have to do microservices in order to have an application that works well. In fact, doing it when you don't have to is going to lead to more problems than benefits. But if you are going to do it, you want to do it intentionally and at your own pace. You want to set up really good observability so you actually know what's going on instead of doing what you feel like you should be doing. And you want to be able to have the ability to take a step back and try something different if one approach doesn't work. If you are a .NET developer, which it sounds like all of you are, Aspire is a really good place to start with that. Now, I'm going to leave the rest of this time for Q&A. I have a microphone over there. I also have a GitHub repository with, so I pulled that recording out from a 5-day-long workshop that walks you through beginning to end, like, think adding Aspire to your application, all the way to adding Redis, adding Postgres, adding like ways where you don't have to deal with connection strings, and all the way to production. There's also a QR code for leaving feedback, because as much as I appreciate multicolored cards out there, unfortunately, that doesn't actually give me a whole lot to work off of, right? I'm like, oh, I got a red, cool. Like, I don't know why. In conclusion, thank you all again for coming. Hopefully this was more or less entertaining and you learned a few things. And have a great last day of your conference.
So you said that you support OpenTelemetry out of the box, and you've got a cool local development gadget. How does that translate to once you deploy it? How do you configure that to send, I guess, to Azure Insights or to another vendor?
Yeah, so there are ways to port it to whatever you're actually using. So you're still getting the live data coming in. It's still using OpenTelemetry. I think there's some DIY you have to do right now to get it working with Insights and Monitor and so on. Happy to share more information about that too. But yeah, it's extensible. You're not locked in.
Thank you.
Nice dress, by the way.
Hi, thank you
Hi.
for the talk. As a developer that makes stuff in the cloud, do you say it would be reasonable to always think, of course, I'll try to use Aspire for this? Or would you be more selective in what kind of projects and solutions in the cloud you actually use Aspire for?
Yeah, so I'll be honest here. Aspire works for a lot of scenarios. It's like an easier way, but you don't have to use it for everything. It's not like, I mean, similar to the microservices thing, like just because you use Aspire doesn't mean that it's going to be good. Aspire is pretty good for when you want to bootstrap things. You want to get a sense of how things work. If you're already a Kubernetes expert, Aspire might not, like Aspire as a whole might not give you something incredibly, all new out of the box. But there are individual pieces that you can pull out and use. So for example, if you want the dashboard, just take the dashboard. You don't need all the orchestration stuff. You don't need all the containerization stuff. So to actually answer your question, take what helps you. Not every part is going to help with everyone.
Gotcha, thank you.
Hello. As a developer that doesn't use cloud and hosts all our applications in the Windows services, would Azure help there? Or
Oh, sorry. Can you repeat the first part?
we host our apps on the Windows servers instead of Azure.
Yep.
I'm thinking, could Aspire give us the same functionality there, or it's only in Azure it works?
Yeah, it works way beyond Azure. Azure is just, it's Microsoft, right? Like they're going to point you towards Azure. But if you're dealing with, I've talked to people who, work in the healthcare industry. They have requirements that mean they can't actually use Azure or AWS. This is all just .NET 8 still. You can take the manifest and you can still use it to deploy to your own servers. And yeah, it's not just Azure. Anyone else? There you go, all right.
Hi, thank you for the talk. I have a small follow-up question.
Yeah,
does
absolutely.
it mean that as you can use some manifests, that means that you can use Aspire only to generate them? So you're not deploying with .NET Aspire, but you create all necessary manifests like Docker files, Kubernetes manifestos, everything.
Sorry, can you repeat your question again? I'm sorry, my
So
brain
my
is mush
question,
right
okay,
now.
so my question related to previous question. Then you used during the answer
manifest.
used the healthcare industry, and they cannot use public cloud. So, but
That's
you
right.
mentioned that they can use some artifacts from using .NET Aspire as manifests to upload to the cloud. So .NET Aspire can generate those manifests. And what manifest types we are speaking about here?
What managers?
Manifests.
What manifests? I'm so sorry. So what I'm hearing is, this is about the previous question about taking artifacts out from what Aspire does in order to make it work with your own individual scenario.
Yes.
Is your
What
question?
what artifacts .NET Aspire produces? So that I can use to deploy to other clouds or servers.
Yes, you can use Aspire to deploy to other clouds and servers. Are you asking about what specific artifacts that you can pull out?
Yeah.
Okay, well, you can pull out the manifest. You can add in the Aspire packages, and essentially you have everything for local development, and then you can have the manifest in order to deploy it to elsewhere. But the local development one is just, you can use it for everything.
Okay. Thank you.
Yeah, I mean, I put my contact information here on the screen, which I may or may not regret. Please use this responsibly. But if I totally flunk answering your question well, please reach out to me. I really do want to clarify stuff because I know Aspire is something that, there's a lot of talk about it. It's not super clear sometimes what exactly it does and what exactly it provides. And I can actually connect you with the actual .NET team to talk more. Great, thanks.
Hello. You were talking about one of the sort of pitfalls of microservices being synchronous communication between services.
Yeah.
Is there anything in Aspire that helps facilitate asynchronous communication, messaging
Yeah, I would
between
say
services?
for that, looking into the Aspire packages is a good option of seeing what's already out there within the microservices ecosystem that lets you go with the best practice of not having services that crash and burn if it's counting on asynchronous communication from somewhere else. I don't have specific packages to recommend, but that's a good place to start.
Is there something in the dashboard that facilitates overview of multiple services?
Yeah. So the dashboard can help you identify those inefficiencies because I wasn't able to go into detail, but you start off with an overall view of, hey, here's your application as a whole, here's each of your services. And then you can go into those individual services and say, how are they operating separately? And also, how are they communicating with each other?
Super, thanks.
Sure thing. All right, the floor is clear, I suppose. Though I saw someone stand up a little bit. Okay, cool. No pressure. I'm not trying to cold call on anyone. I'll let you all go then with 1 minute to spare.